And all that.
Hey there, Joseph. Were you saying that you're sick?
Yeah, I have a bunch of sick students and it somehow caught up with me. So
Yeah,
I,
I sympathize. I'm getting over something myself. I'm not sure what it is.
I look like Rudolph the Red-Nosed Reindeer right now. So which is why I don't have my camera on. But I'm
Every
here.
time, great. That's wonderful. Every time I get sick, it's the same. I turn into Rudolph, but not this time. It's something different. I did take a COVID test, and it said negative, but the home tests don't always register with the new variants, and I wouldn't be surprised if I've been going through COVID the past couple of weeks, but starting to get better. I'm on antibiotic, but I'm at like half breath capacity and drugged up on cold medicine. But we'll see how it goes.
Well, yeah, well,
I
that's what I'm worried about is because my chest feels very compressed and
Mhm.
like it hurts and it doesn't feel like a normal cold. So
Yeah, and like the first 2 days that I got it, it was weird. I felt like not just lightheaded, but like my brain was disconnected from reality and I was kind of floating through reality. It sounds very COVID like. And then everything was okay for a day or two, but then just developed bronchitis and on antibiotic now. But yeah, um, the home tests don't necessarily register the new variant. So you may want to go get a an actual doctor test. Anyway, I hope you feel better soon.
I have a quick question, a
Yeah.
scientific question. So how do we so people we say that universe uh, started with a Big Bang
Yep.
and so many years ago, and how what are the experimental signatures? How do we know
Oh,
how do we know that?
there are a bunch of them. Um, uh, one is the Hubble expansion. We look at all the galaxies out there and measure their redshifts. And other than local scatter, Doppler shifts due to local scatter, they're all moving away from us. And the farther apart they are, the more they're moving. You may want to jump ahead and take a look at Lab 8. We go through a lot of the misconceptions of the Big Bang and evidence for the Big Bang. But I mean, there's a ton of evidence, more than we can do right now. One big piece of evidence is the cosmic microwave background. It is a thermal signature, and you only get that if the gas was in an opaque state at some point in the past. Right now, the universe is transparent, right? We can see through it, but everything's moving apart from everything else. So you reverse the clock, and everything's on top of everything at some point in the past, and it'd be on top of everything enough to be opaque, creating the conditions for thermal emission that then gets released as you expand. Other lines of evidence are the nucleosynthesis. You keep going back far and far enough, and then the conditions everywhere in the universe are like the interior of a star. And so the protons fuse, forming helium nuclei. And you can work through the math. Given the amount of time that you're in the state, you produce a certain amount of helium, a certain amount of deuterium, and lithium, and it all matches what has been measured observationally. There are like two or three other lines of really solid evidence as well. So we refer to the Big Bang theory, but it's kind of like gravity is a theory. Like if I drop this pencil, we all know what's going to happen. There's a tremendous amount of experimental evidence showing that we understand gravity, um, both in its um, low strength limit and its high strength limit through relativity. And can go on, but you may want to take a look at Lab 8 in advance. And the textbook's also good there too.
appreciate it.
Yeah, man, but there's a huge amount. It's not like in the 60s where it was just an idea. It is a work, it's not a theory as much as a working model these days. And when you get to that with students, it's important to impress upon that. Impress them with that. Impress that upon them. Sorry.
Oh,
Brain is just fuzzy today with the cold medicine.
So since energy is constant and everywhere, and then the universe is a matter, let's say, because these are the what we can see, and that's why it's like a something inside the water, or some solid thing inside the water, and that is the universe, and water is the energy, and that's why the going like a expanding, testing, and compressing, or maybe converting everything into energy and back converting energy back into the matter, something like that. Can one think of?
Yeah, early on, the energies everywhere were tremendous. And it's, of course, important to remember this is not like an explosion, an expanding explosion in space. Space is uniformly filled. Space could even be infinite. Even at the Big Bang, space itself can be infinite. It's just infinitely dense everywhere. As it expands, things are pulled apart from each other. But you have these very high energy conditions in the early universe that can then create matter and antimatter particles. And in fact, we think the dark matter is probably some exotic form of matter that was produced in these early times that is very weakly interacting. So it never annihilated with itself, and it's still just kind of floating around. And there's some evidence for maybe annihilations at gravitational centers like the center of the galaxy. There's some extra gamma ray emission. Anyway, good questions. Yeah, I mean, it's an exciting topic, and it's one that our students should be confronted with. And we will get to the stuff by the end of the OPIS sequence, both in OPIS Lab 8 and then the upcoming Lab 9, both tied to the expansion in Hubble's constant. Brett.
Hi, Dan. Sorry you're not feeling well.
Thank you.
So some of my students with their first images had some trouble. There were some pictures that looked like they were the observatory or the telescope or something, and there was a few blank shots. And I heard someone else say that they got a little of that last week. I'm just wondering if there was something systematic that happened. And then
no, go ahead.
Yeah, I was wondering about that. And then just on a hopeful note, is there any chance of getting Sierra Tololo back anytime soon?
Well, they're holding their cards very close to the chest for legal and insurance reasons, is the line that we've been given. But they're certainly taking it seriously. They've conveyed that. They're doing everything they must do to fix whatever has happened that they won't tell us. I'm hopeful we'll get it back in a week or two, but I can't make any promises. As for the weird images, send me a few examples, and particularly observation IDs. I would say about 20% of observations will come back problematic, particularly with our Cerro Tololo site out. But if they're using the other prompt sites, usually it's good. There was extreme focus problem at prompt USASC this past week, and so you may see some images that look like just giant circles with overlapping. It was way out of focus, and they need to be resubmitted. Some can come back purely blank. It could be a dome failure or a cloud failure, but this is what real astronomy is about, and probably 20% of their images will need to be resubmitted. And that's why we have that section in the lab that we go through not all, but many of the ways in which it fails, and they should feel free to resubmit, particularly planetary observations. They're so inexpensive, it doesn't hurt to resubmit. Though sometimes people will look at an image of Saturn, let's say, and it's a big blur and they don't see any stars, and there's actually nothing wrong, or any moons. but there's nothing actually wrong with it. It's just a brightness and contrast thing. So anyway, and Britt has her hand up.
Yeah, thanks. So speaking of the shutdown at CTIO, I was just at a meeting at NSF the past 2 days and talked to Chris Smith. And I asked him if they'd be back up during the semester. And he's like, when does your semester end? October 5th? And I was like, well, that's adorable. No, it ends in December. And he seemed to think it would they'd definitely be up by the end of the semester, but couldn't promise sooner than mid-October. So I guess my question is, if we need to be building in more time for the students to get their observations, or if you think everything is going just as fast as normal.
I think it'll be okay. We have lots of scopes on the system. We just don't have our elite scopes on the system. And they're elite not just in terms of the seeing conditions, but in terms of it's almost always clear and hence reliable at Tololo, except during our summer, their winter. But during our semesters, it's almost always perfect and beautiful there. So it's a great resource to have. That said, what I recommended is instead of going through and selecting what prompt telescopes we have left, we have one in Meckering, Australia, one, and now a second one. I need to add it to the list up at Sleaford in Canada, though still, they have long days. Well, we're getting into fall soon, so that will switch around. Instead of that, to hit the little orange button on the telescope selection page on the right, there's a list of all their telescopes. There's a little orange dot. You do that and selects all the telescopes they have access to, or they can click them manually one at a time and just use everything on the system. And you will have a higher fraction of images that you may want to reshoot because of that, because you're using some non-prompt telescopes, some of which are quite good and some of which are less good or less reliable. But they'll still get images back. They'll just have to do a few more resubmissions, and I think you'll be fine. Now with Lab 1, I often give an extension. I build it into my plan that I'm going to give an extension simply because students underestimate the amount of work. They think, oh, I'll do this the night before. No, it's not going to work, not with these labs. So some additional time is kind of always standard with Lab 1 until they get the gist of, oh, I need to start a few days early. But I think we'll be fine. We're in much better shape than we were during the pandemic when observatories were closing simply because they couldn't have staff there, so they wouldn't allow the telescopes to operate.
Great, thanks.
I think Joseph was next.
Yeah. So can you hear me?
Yeah.
Okay. You sent out an email like about 12 hours ago.
Yeah.
And, yeah, so
that. I'll hit that first.
Okay, yeah, just go at it.
Yep. Let me get Judy first, though.
All right.
Hey, thanks. So my students have gotten a bunch of images back, and a couple of them also, particularly with the planets, got nothing. So I was going to go in and see if like maybe they put them all in a row, so maybe it was all the same telescope, and if there was perhaps that site. So we had a great little brainstorming session, but I thought afterwards I would go in and look more carefully. So could you remind me, I went to Skynet and my observatory and I'm managing my group, but I'm not sure how to see my students' images.
Right. So and normally what my students do is if they have a problem, they send the observation ID number. And then what I do is I bring up one of my images, and in the URL, I just replace the observation ID number, and you can then see their page.
Okay.
Skynet 2, I'm trying to think in Skynet 1. So in Afterglow, you can certainly navigate. I have to think for Skynet 2, Skynet 1 in a second, but in Afterglow, you can go open file, instead of going to user observation, just go to group observations, and you can see all your students. Then you can go in and then find their observations, and if they're reasonably named, you can figure out which one's which and take peeks. I don't think we have that same navigation in Skynet 1, but we will in Skynet 2.
Okay, but we do in Afterglow.
Yeah, in Afterglow you do, but usually students will say, is this right? and have them send you the OPS ID and you copy and paste in the URL and their page.
Okay, got it. All right, thank you.
That's why in lab 1, which segues into the email from last night, we've added something so we update the labs periodically, and we updated labs 1 and 2 this time. And one of the additions we made to lab 1 was they list their Skynet observation ID number. And so you can just grab it right out of the lab as well and go and check. Of course, by that point, it's a little bit too late. By the time you're grading the lab, they've done it, but at least you can go and check out their observations if something doesn't look right. Now that led to a problem. And so this is the email from last night. I guess I'll share my screen and explain it a little bit better.
Hey, Dan, could I ask you one quick question about what we were just talking about? Just one thing. I know in the previous tutorial, you suggested alternate filter sets for if a filter is not available, but with not having all the prompt telescopes we usually have, I was having a little bit of trouble substituting. So on your list for Jupiter and Saturn, which are super bright, I'm sure low through is a good alternative to what's on the list. But for Uranus and Neptune, what would be good alternates for those dimmer planets?
So let's see, let's bring up lab 1. And so lab 1 uses, it's up here. For planets, we have new recommendations compared to, reloaded it, compared to previous. Now we use U and B, before it was U and B. U is not available on all scopes, so the pickings may be a little bit slimmer, but most prompt telescopes have full filter sets. We actually worked with, I forget who it was, but one of your standard filter wheel makers to make a 17 slot filter wheel. So we can get like almost everything on there. The moon's here, it's B and high through. Dwarf planets, it's high through. These should usually work. If you're having trouble finding a U filter, you could go with low through.
Okay.
But it's best if you can find a U somewhere. The rest are high through. So this is using U, B, and high through.
If there's a problem finding a B, what could we use?
I'd be surprised if there's a problem finding a B.
Okay. So they should all have Bs.
Yeah, that's a pretty common filter. It should be much more common than U.
Okay.
But if I'm wrong about that, send me an email and convince me. Let's see, for the moon one, we say the low through is sufficient. All right. Now this issue, let me bring, let's see, I just had it up, lab 1. Let me show you that addition we made in that's not lab 1.
OPT makes good filter rules. So, or I think they do.
OPT?
Yeah, I think so. I don't know. They're kind of cheap.
The filter provider. Yeah. Mm-hmm. Yeah, I'm trying to remember. We used to get Astrodon, but they don't. I think they sold.
Oh yeah, yeah, they're good too.
Astrodon's one of the better ones. The Botter is pretty good, and Astronomic is pretty good as well.
Yeah,
but Astrodon's really one of the state of the arts.
Yeah, I think we usually get Astrodon. Most of our filters are Astrodon,
and they're expensive. UBV, a UBVR set is like $1,200.
Yeah, I mean that's what you want in prompt, right?
Yeah,
we probably spent $100,000 in filters over the years across all the.
It's actually money well spent, though.
Yeah. Mm-hmm. And there's all sorts of with narrowband, there are all sorts of interesting discussions because they have like 3 nanometer, 5 and 7, and they're good for different types of observations, but that's more of a MWU kind of question.
Yeah.
Anyway, the thing that we added many things in the lab, I pointed them out last time, but one of the things is after they submit their observations, we now have these little tables where they put their observation ID numbers. They're not worth any points, but it's just an aid for you. If you want to go, something doesn't look right, you can go and check out their observation. Perhaps it can also be used to examine cheating, right? But the thing is, it added a number of new boxes. And the way these labs work, let's go to WebAssign again. And I'll bring up lab 1, edit. And it turns out if I created a lab for you, you can't edit. So I'm going to have to correct these. It's one of these things where I wish I got it right. I make my own version, get it right, and then make copies for everyone. Any error I make gets copied to everyone, and then I have to edit them manually. So this is going to take me all day to fix it for everyone. But here are all those boxes. Remember, this one's in 2 weeks. The first week, there are no questions. That's just the instructions for submitting. And the second week, here are all the boxes. And here are the values that they're worth as stated in the lab. If you want them to be worth more or less, you can edit them here, but it won't change the statement in the lab. And you have lots of zeros for the things that aren't graded, things that are in tables where you have like a box after that you do a grade. Anyway, when they added these extra boxes with the observation IDs, they just added a bunch of zeros at the end. You can see them all here. And so what I need to do is go through and redistribute these points. And last night I figured out the sequence of where they all need to go because they don't make it clear which box is box 2N, for example. I got to sort all that out. And so these need to be reshuffled, else the grading's not going to be correct. And so I'm going to go through this and start doing this today. It will be tedious, but I think for all of you, I created your sections. For any of you, did you create your own sections? For some people, because they're LMS, they create their own sections and copy the assignments over. Okay, so
no, I have no edit box, so or the edit's grayed out.
That's right, because I created it for you. The edit website only, I can't give you, if I could give you the permission, I'd give everyone the permission from the get-go and say, everyone just go do this, and it'd be so much easier than me doing it 30 or 40 times. Because it's not like I can copy and paste. I have to go to each of these boxes, turn that into a 0 and bump this one down. And it is a terrible process, but it's my mistake because I didn't think to update this before distributing. Fortunately, the lab 2 updates, there were no additional new boxes. So I'll be doing this today. Hopefully most of you haven't gotten through lab 1 and are doing grading now. If you have, then email me and I'll prioritize you. So that's what that was about. It was a long email chain as we're trying to figure out what's going on here. I apologize for the confusion. Okay.
Dan, I have one more WebAssign question.
Yeah,
while we're still on that. So I'm trying to mimic what the students are going to do just so I can see how it all works out. And I can't upload images. So like when I go to choose the file and put in my image of Jupiter, it doesn't show up. Is that just because I'm the teacher in the course and I don't actually have a student account?
I
mean, I can type into boxes, like I can put in numbers, but when I do the choose file and pick an image.
Let's try this. So I'm going to upload an image here. And there are size limits. So it would actually have to be, let me grab an image from Afterglow first.
I didn't check. I went through the whole Afterglow thing and I did the camera button. But then I didn't go back and check the size.
Well, it should be the right size.
Okay.
Okay, so I just downloaded one. Coming back here, since I pressed that button, it's going to reload the page.
Just to chime in on that, my students also have problems with that too. They clicked the button and it wouldn't do anything.
File name rules. So let's see here. Download. No special characters. That's interesting. Let's see if so I didn't see any special characters in there. Let's try this one more time. Maybe they've changed their file name rules.
Well, there's a couple dashes and there's an underscore in there. Those
Yeah,
could all be considered special characters.
yeah, they could be. So let's see here.
Mine was just called Jupiter 1 JPEG.
Okay, mine's called Afterglow Screenshot. That should be acceptable. Okay, that one took. So in my case, it was the underscores and the dashes.
It could be it could be spaces as well that's screwing it up. You could try that by putting a space between Afterglow and Screenshot.
Yeah, what I did was tell my students not to use any underscore spaces or anything. Just keep it all one word. Right.
Yeah,
Eliminate the ambiguity.
it
Right,
took,
took
took
that.
the space, but it must have been the dash or the underscore. That is disappointing because we do in the names, it is very useful for them not all to be named the same thing, that they have some unique identifier. Because if they all are named the same thing, then your computer saves it parenthesis 1 unparenthesis, parenthesis 2 unparenthesis, and those are special characters. And so we had been using these timestamps, but if they now count as special characters, let me just try one more thing to see if an underscore works, because we had a mix of underscores and dashes. If one is acceptable and the other is not, we can change our naming scheme in Afterglow.
I don't think underscore is going to work.
Took it.
So now try a dash.
Yeah.
Yeah.
That's the thing with high-tech labs. The tech is always changing. So this is,
Okay, so the other thing that's in here that could be confusing it, right? You know, again,
maybe it's the length.
well, the length, but also it had more than one dot in it. Right?
Let's go
When-
back to the original. I'm gonna just download it again.
See, because it's got a dot. It's got 2 dots in there, and if you were not
Oh,
adequately programmed, that might screw it up.
that is probably it. That is it.
So if you take that out,
WebAssign. Oh, it's down here. Sorry. Okay, that loaded. Now I'm going to put the dot back in. If that's the case, we will remove the dots. Yep, that's
Yeah.
it.
that's it.
Wonderful. I don't think it was an issue before, or no one reported it before. No
That's
dot.
what happens when you get a bunch of physicists.
Uh-huh.
Oh, my first graduate degree was in computers, so I love debugging problems, code problems.
I'll let Josh know this, and he will add it to the change list in Afterglow. That the screenshots do not include a dot, which is,
No dots whatsoever.
well, no dots in the file name. Of course, there'll be a dot before the extension.
Right.
And it
just sync-
automatically adds the extension.
Yep. Yeah.
Okay.
And so it was probably trying to interpret anything past the first dot as the extension, and then that extension wasn't recognized by Cengage.
Yeah.
Yeah.
So what mine is doing, and I can find help elsewhere if this is just my personal problem, but I'm on the same page and I go to choose file next to Jupyter, and then I go to where I've saved all my images and I can see it. But when I choose it, it just shows up as the word Jupyter1.jpg. It doesn't show up as the image.
Oh, okay. Yeah. So you don't see it here, right? Well, right now I'm in answer key mode.
Got it. Okay.
Let me hide answer key mode. Let's see, if I press none here, it'll look like what the students see.
Okay, so this is because I'm in the instructor version.
Yeah, and
Well, I'm
so
not saying great.
the students are seeing something like, it's down here. Here we go. Right, and they're just uploading their files.
Yeah, and there's just gonna tell them what it's. Okay, okay, good. I thought it had to do with whether I was a student or instructor or whatever, so
When
answer
you,
key mode, I will be able to actually see their images.
yeah, when you're grading, there'll be a link. There'll be a link, and you'll be able to bring it up. The picture you saw there was the answer key picture, which is just,
Awesome, thank you.
yeah. Okay, so we're all learning things here. All right, so what was on our agenda? Let me see here. Talked about that. So last week we completed Lab 2 Stellarium. I've added 2 videos from a couple years ago. At UNC, we do the Globe version, and so here I'm going over the Globe version with my TAs. So if you are interested in the Globe version, you can watch these videos to see what that's like. Again, with the Globe version of Lab 2, we do it as a 2-week lab, kind of a 1.5 week lab. And we're going to do the Lab 1 optional color combination in the second part of Lab 2, week 2. It takes longer to do the Globe version because of all the manual measurements. It's a slower going process, and they can't finish it at home because the experimental setup. But those are there now if you're interested in that. And again, if you want a parts list, Anna did, and I sent it to her. I dug it out. Next week, we're going to not talk about Lab 4, but accessibility and grading. So I'm going to show you how to do grading in WebAssign, and we'll have our accessibility expert come and talk to you and pitch you to try to recruit BVI and DHH students and the additional support we offer in that case. But today we're doing Lab 3 and the observation for Lab 4. So let me bring up Lab 3 here. Now I'll pick up the pace a little bit, make sure we get through it all. So standard beginning, we have the overview videos, intro background procedure, the observation guide, telling them, just reminding them, make sure you're placing your observations in time, and a reminder to review their sources of error in the previous lab. The videos, again, are all on the main site. We have the original versions and the accessibility enhanced versions. I still like the originals, but a lot of people like the accessibility enhanced. Here's the Lab 3 playlist, again, with those 3 overview videos, very short, just a couple minute introduction as to what's going on in this lab, overview of the background, overview of the procedure, and then the how-to videos, which are also interspersed in the lab. Go back to Lab 3 here. The observation planner, let's bring that up. So here's the observation planner. It's a Word document so they can edit, and they've already filled this out, letting them and you know when to put in their upcoming observations. And we always talk about the submission of the upcoming observations ahead of time in these training sessions. So for Lab 4 and Lab 5, you notice the asterisks, which means the instructor will place these observations for the class. In the case of Lab 5, it's a very lengthy observation. It's going to be a repeated, like 50 observations of an RLI, and they're pretty long exposure times, more time than any one student has. And so the instructor puts this in for the whole class. In Lab 4, it's not necessarily lengthy, but it's tricky in the sense that we're going to do a number of parallax measurements in Lab 4, but the one that we're collecting fresh data for is the distance to a main belt asteroid. And to pull that off, you have to image simultaneously using telescopes both in the northern and southern hemispheres. On our side of the planet, we don't have enough in the north on the other side to go with Australia. So the idea is an observation from Tololo, which we can't do at the moment, but hopefully by the time you get to Lab 4, you'll be able to do it. So I'm going to show you how to do the observation today. and then another telescope up north, and we have a variety of options. And the thing is, you have to image simultaneously. And so, this is a queue scheduled system. The system decides when is the best time for every observation to go through. And if the weather's bad, it holds it and does it later. To achieve an observation at a specified time requires a higher permission, target of opportunity permission. And I'm willing to give it to you, but not to everyone. Brett, go ahead.
Yeah, this is one I had trouble with last semester because, well, one thing was I was terrified that I was going to abuse your system and then lose my privileges. So I was really nervous when I was trying to schedule this, and I don't think I pulled it off. So I don't know what my question is exactly, but I do remember I was very anxious about this lab.
Oh, first of all, you don't need to be anxious. I'm not a meanie. If you make a mistake as you're trying to learn, I'm not going to punish you. The point is, don't use the TOO outside of this observation. But in this observation, you're welcome to try. It often takes a couple times because maybe you set it up and weather doesn't work in one of the two sites. So you got one observation, but not the other. And so often we have to do it 2 or 3 times. Once you get good at doing this, you can pull it off every semester. The first time will probably be the trickiest time. It is the trickiest observation in this sequence. And we're hoping in Skynet 2 to make this a little bit easier. Right now, we're kind of jimmying the system to make it work. And there are backup observations in case you fail. Now, if we come back down to lab 4, there's some hints here. Again, the instructor is responsible to place it. And we strongly encourage you to practice ahead of time, get all ready ahead of time, but place the observation in front of your students. And if you have to resubmit because of a weather problem or technical problem, you could do that on your own. But it's important that you don't put the observation in your office and just show up to lab and say, okay, I've submitted this for you. Our education research shows that data ownership is a big part of what makes this special to the students. Of course, the best thing is them putting in their own observations. The next best thing is it belongs to the class. It doesn't really belong to the class if you did it separately from the class. If you do it in front of them, they feel some degree of ownership with it. And we're actually studying how much ownership they feel there. Okay, let's see what else is here. It's tricky, as I've already said, and I'll explain why. We recommend that you prepare it ahead of time, but then do it in front of them. Since weather can ruin one of the observations, you're going to be checking weather reports before you schedule weather.com, and you may have to repeat it a couple times. And once successful, the instructor will tell the student where to go to find the specific observations. And I say this a little bit in jest, so don't take it personally. If your instructor utterly and embarrassingly fails, do not fear. There are backup observations. This was written this way because instructors do have it, since those backup observations are there, the easy thing to do is just to lean on them. And this is to kind of gently prod you to try to collect observations for your class every semester, instead of just automatically going to observations that may be 5-10 years old that would be less exciting to the students. Okay, and those are kind of the general pieces of advice. If we go to the lab, so this is lab 4, and I've jumped down to placing the observation. This is the same stuff I just told you. There's a tutorial that goes through this in much greater detail than I'm going to in the next couple minutes. So do not fear. And then some important things to remember and links to weather.com's page for each observatory. Though I need to add a few observatories that have come on since I last updated this. Okay, so how do we do this? First, we have to pick an asteroid. And in the lab there, it links you to Wikipedia's page of exceptional asteroids. Now, you can just ask me, because every semester I figure out what's the best asteroid to do. But let me walk you through the process a little bit. So the instructions say, start with ones below 300 kilometers. If they're too big and too bright, you have to do shorter exposure times. You won't get as many background stars. We may not get plate solution, a WCS solution for the image. So we always start with Davida, I'm not sure how it's pronounced. Go to Skynet, and you just work your way down the list until you find a good one. So I'm going to go through this process a little bit so you understand what it means to be a good one. So keyword, I am, let's see, add a new observation. Davida, search. Make sure it's on the asteroid, because sometimes these things, you have multiple objects with the same name. And let's start with Tololo. Here it is. It doesn't really matter what telescope. Tololo and now. So there's the sun. And I'm looking, and there's Davida. It's pretty well separated from the sun. If the asteroid, when you're doing this lab, is too close to the sun, it's not going to work. You want something close to the other side of the sky. So right around there, it becomes observable. And then you want to check Sleaford. That's our observatory in Canada. And got to go a little bit farther in time, but you see it's way too low in the sky in Canada. So yeah, that would be fine for Tololo, but not Canada. So what's next in the list? Sylvia. Sylvia, and oh, it's also very low in the sky. So what's next in the list? You know me, etc. I had to go all the way down to Cybele, I don't know. But I'll show you an example of the good one, kind of what you're looking for. So let's go back to Cerro Tololo now. And as the sun sets, there it's coming up. So it's late, second half of the night, but pretty late in the night. And, it's off the horizon. It appears to be about 40 degrees up. So that's good. And there's a long span of time when it's observable. Let's go to Sleaford and check Sleaford. And it also looks pretty good here. Maybe I'll come back around here for Sleaford. And let's check out Tololo. Now that's pretty good. Maybe if I go forward, you kind of want them both kind of in the middle of the sky. Oh, that's the sun's getting ready to rise, so I don't want to get too late. Let's say 5 a.m. Here it says 4:40, so let's around 5 a.m. is good at both sites. Did you see the game I just played? Okay. Or if this is too confusing, just email me and say, Dan, what's your asteroid this semester? And I'll say, oh, it is blah, blah, blah. Okay, so it's Cybele is probably the pronunciation, Cybele. And I said about 5 a.m. Eastern time. When we're going to need to get this in Greenwich Mean Time. So we're in daylight savings time, add 4 hours. So 9 a.m. GMT. I'm writing this down because I'm going to need it in a little bit. 9 a.m. or 9 o'clock GMT. Okay. Let's check our parameters, minus 12, 20, 0.5. May want to make sure the moon is far enough away. I don't see it anywhere close, so that's good. We don't need the special functions, and save and choose filters. We're going to use high through, save and continue. And let's do Tololo first. And I think everyone currently has access to prompt 5. Now, if you're new, you don't have TO access. As this lab is approaching, you have to send me an email and say, I'm getting ready to do lab 4. And I'll give you TO access on one of the telescopes in Chile. I think I currently have everyone on prompt 5 and a handful of telescopes up north. So I'm putting in the Chile. And with TOO observations, you have to submit a separate observation for each telescope. You don't have one telescope with TOO. So prompt 5, save and continue. I have it set to prompt 5. Don't set it to generic. This is all on the instructions. And we're going to do 15 40-second exposures, a 10-minute block. Now, really, we just need one exposure simultaneous between the two sites. And even though we can get the two observations to start around the same time, one telescope may be wrapping up an observation and maybe it has farther to slew. So it may be a minute, minute and a half late. So that's why we do a 10-minute block. Somewhere in that 10-minute block and the other telescope's 10-minute block, there will be decent overlap. So 15, 40-second exposures. And here's the deal. We're going to delay the start of this observation until, well, you have to pick a day and a time. We said 9 o'clock GMT or UTC. And as for the day, you check the weather. So you go to the lab, and I'm going to look up Tololo, and weather looks great. We can do it tonight, whenever. So let's check out our other site. And you'll also have a backup site. You want to check all three. Let's see, the other site, Prompt, Saskatoon, the Sleaford site. And it looks not great tonight, but then clear. It looks clear on Thursday. Thursday looks good. Wednesday just, well, we're in Wednesday, and so it'll be Thursday at night, mostly clear. If we go down, it looks really good the next night. Let's go for Friday. Okay, so back to Skynet, and we're going to select Friday, which is the 22nd. I've already practiced, so it's already there. And what you do is you copy the start time, set it to the cancel time, add 10 minutes. And this way, if suppose one site goes through, but the other site's clouded, instead of holding the observation and doing it later when it's useless, if it doesn't get it done in those 10 minutes, it won't do it. You won't be burning TOO time. TOO time stops everybody else. So we try to be courteous. You set your 10-minute window. If you don't get it, then you just put it in again. Save and continue, and then you submit. And I'll submit. And then you do the other site, and maybe even your backup site. You can put in all three. Show you how to do this as soon as it updates. And so you go back to the site, resubmit. Telescopes, my other site was not prompt 5, but prompt USASC. I skipped a key thing, so I'm glad I went back. I'm going to set it to prompt USASC 1540. And the thing I forgot to mention before, but you got to check each time, make sure your target of opportunity is flagged. That's right there. And then in the future, turn that off. And again, it's going to be 9 o'clock. It always resets the cancel time to a month later, so you have to go and do that again. 10-minute window, save and continue. Submitting. Slow, not sure why. It'll get in there. Then I have my 2 observations good to go for 2 nights from tonight, and then I'll check them. And if I'm good, I'm happy, then what I do, hello computer. Not sure why it's jammed right now. But what you do is when the observations come back, you bring, here we go. Let me go to one with multiple observations, even though this was something else. You see the times here. Bring up both observations, figure out whichever one started second. Find the time of the first observation. So the second one, the first one's already going. The second one kicks in. Take that first observation, as long as it looks good. Then find the one closest in time on the other observation. And So, with this observation, I want 0, and with the counterpart observation, it may be image 4. And then you tell your students, okay, we got the observations. In Afterglow, you're going to go to the group, into the instructor's account, into these observations, and grab these exposures from each. I did that kind of fast and sloppy. And if you feel scared and intimidated, watch the video that's in the lab. It should present it a little bit better. And of course, you can always fall back on the archival data. Okay, questions about that? Hopefully in Skynet 2, we can find some ways to make it a little bit cleaner to submit this thing. But basically, we're tricking a system that was not designed for it into simultaneous observation at 2 different sites. It takes a little bit of planning. Okay. And there's no shame in using the archival data. Frankly, when I teach this every summer, I'm lazy and I just send them to the archival data. I shouldn't, but I do. Okay, lab 3. In our final 9 minutes, we probably won't finish it, but let's get it started. Where is it? Skynet lab 3. Okay. So the goals of this lab, they're written here. Measure a moon's orbit. Excuse me. Let me get a drink. Around a planet. And they've been collecting this data for like 2 weeks now, right? They picked one of the gas giants that's currently observable. Once a day, they're watching the moon go around. We talked about how to put this observation in last time. They're going to use this data to figure out the orbit of the planet here, and then the mass of the orbit of the moon going around the planet, and the mass of the central body of the planet. Also, there's a part at the end of the lab that I think in a future version of this, I'm going to move to the beginning of the lab, where they measure phases and angular sizes of Venus. And this is to show that we live in a heliocentric universe instead of a geocentric universe. So along the theme of the course of our place in space, as we're working our way out, we did a lab on the Earth and the seasons and figured out the size of the Earth. Next, we're going to show that we're not at the center, that the sun is at the center of the solar system. We orbit around it. And this will continue out. In lab 6, we show we're not at the center of the galaxy. In lab 8, we show that we're not at the center of the universe. So it's a mixture of our place in space and a Kepler's third exercise. Equipment, computer with internet connection. And 2 background sections, one on the Galilean revolution, one on orbits. And the orbits part will lead into the Kepler third activity, and the Galilean revolution part would lead into the Venusian phases. Let's do the Venusian phases, and maybe we'll save the rest of lab 3 for next time. Okay, so this is basic background stuff. You know all this. I'll run through it real quick. Galileo, 1609, took a telescope, did not invent the telescope, but took a telescope, pointed it up to the sky, first person to do so, looked at the 4 brightest objects, made 4 revolutionary discoveries. Each of which today would probably be a Nobel Prize if they had them back then. For the moon, he discovered craters. For the sun, he discovered spots. Though I always joke, if I look at the sun through a telescope, I'd see spots too, because he wasn't appropriately filtered. This is kind of important because by this time, ancient ideas had become church teachings and church dogma. So Galileo had to go against a lot, the power structure of the day. And although these don't have anything to do with our place in space, the ancient Aristotelian ideas of perfection in shape, that the celestial bodies were perfect spheres, and the moon is, of course, blemished, but they thought it was perfectly smooth, and they thought the sun was perfectly smooth and unblemished. So when Galileo saw craters and 3-dimensional blemishes and spots on the sun, that did violate church teaching of the day. Then we move into the ones that are a little bit more germane to the topic. The next brightest things to look at are Jupiter and Venus. Looked at Jupiter and saw moons going around it. And this is not a problem for the heliocentric universe. In the heliocentric universe, planets go around the sun, but you can have moons go around planets, no problem. In the geocentric universe, everything must go around the Earth because the Earth is the central body. Of course, Tycho had his own hybrid system that it's more of a historical footnote, but interesting. And here his original drawings, he saw the moons going around Jupiter. And that's a problem for the geocentric model, but not, and it's consistent with the heliocentric model, but it's not the strongest test, yet it's the most famous of his 4 observations. The strongest test is actually the size and phase of Venus. It differs in the 2 models. In the, here's the geocentric model. Earth at the center, the planets travel on epicycles that travel on deferents. Deferents are kind of like orbits, but a little different. Have dual wheel structure. So here's the Venusian epicycle in the geocentric model. And notice you go from large and new, and as you get smaller, you become crescent, but then eventually new, because the entire epicycle sits between the Earth and the sun. And then you come back, getting larger, crescent, and then new. And so here we have a plot of phase versus size. You start out here big and new. You become crescent, but never more than 50% phase, never gibbous. And then you become new again, and then you work your way back. The width of this is because there's some flexibility in the geocentric model, depending on how big you make the ring, the epicycle. Here's the heliocentric model. And in this case, from our point of view, Venus occupies these positions going all the way behind the sun. So you go from large and new to small and full and back. So that corresponds to this curve, large and new up to small and full and back. So by making measurements of the size and phase, you can see which region or which curve your measurements fall on. And so I'm going to skip over the K3 stuff, save it for next time due to time, but show you this real quick. I should also point out there's some nifty videos in the tutorial, links to YouTube sites where you can see these things moving. They go kind of fast. You may have to play them a couple times. And then there's a tutorial on how to make these measurements, but I'll show you real quick in Afterglow. If they have a Venus observation of their own, they can add it. Or if they didn't get one in lab 1, they can try again. Maybe only about 20% of the time Venus is far enough from the sun for Skynet to do this observation. But there are also these 7 observations that we took violating sun constraints usually, and they're in the sample directory. The lab gives the students the how to find them. They load them up, and very critically, they have to change from default to bright target. So here's when Venus is large and crescent, and they use the measuring tool, which they learned how to do previously. They don't use centroid clicks because we're not going between sources. And they measure 2 things, the illuminated angular diameter, and there's some arbitrariness of where you put the edges. And this is a topic for sources of error, atmospheric blurring, pixelization, and then the diameter is the tip-to-tip distance. They do as carefully as they can. In both cases, they get sizes down here in arc seconds. So again, here's a skill they learned in lab 1 that now they're starting to apply it. Going back to the lab, the phase is, as we define it here, is the ratio of those 2. And so they have their illuminated angular distances here, their angular diameters here in arc seconds. The phase, they calculate, that's the ratio. And then they go to our graphing tool, and they're going to plot them. And so here's the graphing tool. Again, we have the old tool still. Let's go to the new tool. And yeah, sometimes we're trying to get rid of this message. There is no danger. They can go past this, but some students are scared and will use the old tool. We'll hopefully get that message out of there soon. Here's the Venus application, and they put their angular diameters in here, their phases here. maybe edit the labels. Maybe this is phase of Venus versus angular size. And on the x-axis, we have angular size, and this is in arc seconds. The y-axis, we have phase, which is dimensionless. So again, some good labels in there, and then they put their values in and see which they're on. There's generic data at the moment, and they'll put in their own. And then they can save the graph, again, signing their name, so it's in the EXIF data, so they did it themselves. But you get the idea there. You know, they can add points, maybe at 20. They measured 0.2. And why'd they get it so wrong? Well, they got it so wrong because they didn't go to bright target. If you stay on default, then that looks very gibbous when it actually wasn't. If they measure the sky glow, they're going to get it wrong and probably draw incorrect conclusions. We can look at one more of these here. This is when Venus is far away and in that gibbous. And just seeing a gibbous Venus is evidence of the heliocentric model. You never get a gibbous Venus in the geocentric model. Anyway, I think that's it there. This is a very simple activity at the end. The big activity is the Kepler third activity. We just didn't get to it today. There are a few questions about whether their measurements are more consistent with one model or the other, and sources of error such as difficulty due to atmospheric blurring and what shade of gray best marks the edge. But in general, they'll get the right answer. They should get something from the 7 observations. I did the measurements and got something like this. This is the answer key. They don't see that. Questions? Okay, so our goal next time will be to do the other part, the bulk of Lab 3, the Kepler third activity, which is pretty cool. I think it's one of the more fun activities. And I'll show you how to grade, and we'll hear from Kate Meredith at Glass Education on accessibility. All right. If there are no questions, I'll see you all next time.
Yeah, hi
Thanks,
Dan.
Dan.
I just thought I'd
better.
mention that Patricia Craig
Thanks.
couldn't make it today.
Yeah, she sent me an
yeah.
email too.
Okay, great. Yeah, she couldn't get out of that, so.
It's okay. Yeah, I'll put this up on the YouTube site so she can watch it.
Thank you, sir.
All right. See y'all.
Thanks,
Dan,
Ken.
are you gonna be around for another 15 minutes?
Oh yeah, that's right. I'm not gonna close it down, so feel free to stay and chat.
Okay. Kepler was one of my, actually is my favorite astronomer. I feel weird because my camera's not on.
It's okay.
Yeah, I do look like Rudolph right now. I had to talk to Elise yesterday, and it's like my nose was just like bloody red. But
I understand.
yeah, so I'm staying home. But I have to teach like 6 hours tomorrow, so yeah, go figure. How, Kepler was a very interesting person. Really was. Have you ever read like Kepler's Witch?
No, I haven't.
Oh wow. It's such a cool story about his mother.
Oh,
Like,
really? I don't know. I don't know this. So do tell.
yeah. So his mother took him out to see the comet of 1577, I think.
Mm-hmm.
And that's what turned him on to a lifetime of astronomy and mathematics, and he became a monk and all this other stuff. So this leads me into this, how do I explain to up here in Appalachia, and we have a lot of very dynamic demographics, I guess, when it comes to beliefs, right?
Sure.
And I'm not saying that people believe in a geocentric thing. I think everybody agrees that it's heliocentric at this point. But when we go into like where the history is and like that the Catholic Church and like everything was really, how would you approach that from a pedagogical point and not be offensive? I guess.
Yeah, it's a tricky. You got to use a little bit of humor. I have videos of me teaching Astro 101. Let me put that in the chat because I do this lesson here, and you can, if you want, you can watch my approach to it. Let me pull that up right now. I'll find the exact lecture for you.
Because, I mean, we're scientists and like we know this, but
we can't shy away from it. But some lighthearted humor and I point out, look, I'm picking on the Catholic Church, but I'm not picking on the Catholic Church of today. This is the 400 and some years ago, and they've admitted they were wrong about this. And in fact, I joke, when did they I forget exactly how I put it. I put it in a funny way. Forgive Galileo for his either forgiving Galileo. I forget exactly how I put it. It's in the video somewhere. But when did they finally acknowledge that they were wrong about this? Do you know? It's 19.
it was early 20. I mean, it wasn't not that long ago. It was like 2001.
No, it's 92. If I have the number still in my head, it's in the video here. But 1992, they finally admitted, yeah, they screwed this one up. And
yeah, it was they actually pardoned Galileo, I think.
I'm just gonna give you the whole playlist here. Here, I'll share my screen for a second.
Here, I'm here now.
There you go. So I'm sharing my screen, and in the chat, I'm gonna put the playlist here. This is so on the same YouTube site where I have the labs. If you go down a little bit, during COVID, I shot nice videos. One second. Okay. Nice videos of how I teach 101, which is the solar system course. And if we go into lesson 2, which is kind of the history part, and look at the playlist, the first one's on Stonehenge. You can skip over that. But then we get into geocentric and heliocentric models and the Galilean revolution and aberration of starlight, stellar parallax, Tycho, Kepler's laws, and Newton. And so, in here, I tell the Galileo story and, beat up on the Catholic Church a little bit, but humor is a powerful tool. So I do it with a little bit of humor and make it clear I'm not picking on modern day religion. And the fact that they admitted their transgression as late as 1992 is something that everyone can laugh at if you present it in the right way. And you can see how I do that there.
You just have to be very careful nowadays as far as like how you present stuff. I mean, and I'm not saying you, but I mean, like I want.
Yeah, everyone does.
You can get away with it because you're very qualified. I'm an adjunct. Okay. So
no, I understand. Yeah. I mean, you should stick to your guns, but there's a way to do this that's not confrontational. And watch the videos and you see how I handle it. I'm also bringing up, wrong lesson, lesson 2, my slides. I really view this as a great opportunity to teach the scientific method and what the scientific method really is. And so here you can see, here's the Galileo story. There's the moon, the sun, Jupiter, phases of Venus. But I have this figure before it. And then here it is again. And here I'm talking about aberration of starlight and stellar parallax. And you see this figure again. And so I really focus not so much on, the Catholic Church got this wrong, but use the standard history unit to teach what the scientific method really is. And they're often blown away by this because they don't really appreciate what scientific method is. It's not a path of finding truth. It's a path of ruling out bad ideas. And, so I have this flow chart that I've made, and I can send you this as well. But,
Oh, please do.
yeah, basic idea, and all this stuff, but you have a hypothesis, and hypotheses make two predictions: testable predictions or no testable prediction. If a hypothesis makes a prediction that's not testable, that's okay. Lots of things do. Religions do, but lots of things in culture, society does. It's just not science. And it doesn't lead to new knowledge. It's stuff you have to take on faith or belief, and that's part of society and part of our culture, and there's a lot of it, and it's okay, but it's not new knowledge.
Vampires.
Yeah, it's stuff you either believe in or you don't. Okay, and you don't have to pass any judgment there. But if it's a testable prediction, you can test it. You can subject it to experiment or observation, and it's either consistent with the prediction or it's inconsistent. And if it's inconsistent, you've disproved the hypothesis. The hypothesis only has to be wrong once. Now, of course, you got to double check it because humans can make mistakes, but that is actually useful. That's new knowledge. That this idea is wrong is new knowledge. And so you go all the way back and start with new hypotheses. But if it passes the test, you haven't proved anything, because there could be other hypotheses that lead to the same result. What you've done is hypothesis not proof, but it gains credibility. And particularly the more arcane, the more esoteric the prediction, like a lot of the predictions in general relativity or take aberration of starlight. That is a really specific prediction about how stars will appear to move on the sky. And these are things that wouldn't just happen. It's hard to come up with some other explanation for such complicated behavior.
Well,
so
the mutation of the Earth, right?
Yeah.
I mean, it took ages, and it was the astronomer there, I think in England, that had a little hole up in his house. I can't remember his name.
I can't remember.
Yeah, I can't. You know who I'm talking about.
In England, I'm off the top of my head, I don't know.
Okay. Yeah, but he just measured like the Earth, the wobble of the Earth.
Okay.
Yeah.
You can do this
yeah.
in archaeoastronomy as well over centuries and things, but
yeah, it's absolutely like fascinating how much like folks get into it. But no, you're absolutely going back to something you were talking about here. Like I always I tell my physics students, because I teach like 3 physics classes, also general physics.
Yep.
And I tell them, look, Newton, we're going to be studying like balls going down hills.
Mm-hmm.
But don't think that Newton's laws of gravity are laws. They're not laws. Einstein proved it wrong.
Yeah.
Under special conditions, right?
Mm-hmm.
And we found that out with general relativity and special relativity, right? So
yeah, and often as I'm going through that flow chart, I start talking about Newton and relativity. How we keep going through that confirmation cycle, and sometimes something is shown wrong, and we have to. Newton kept going through that confirmation cycle, getting stronger and stronger, but then we started finding problems, and so it was rejected. We had to come up with a new hypothesis, and so relativity makes these really wild predictions.
Yeah.
And they pass, and so it gains tremendous credibility. But even that must be wrong because it's incompatible with quantum mechanics. Quantum mechanics, right?
Absolutely.
And so we're going to go through this cycle again at some point. And so, and this also addresses students. They say, "Well, science, they keep changing their minds," And so going through this flow chart is really, I think, one of the key things we should be doing in introductory astronomy. What I'm doing right now is I'm just trying to find I have a list of links to all those images. I should be able to find it pretty quickly for you. Astro, let's see, I taught Astro 101 this summer.
What I tell my students is to say not wrong. Like your answer is not wrong.
Mm-hmm.
Don't say it's right or correct or true. Say it's not wrong.
Yeah.
And they seem to like that. They picked up on the fact that yeah, they're getting the hang of it. I got a lot of surveys in for you, by the way.
Oh, good, good. So I'm almost here. Here, it's probably this one here. There we go. So let me give you, I'm going to put a couple links in the chat. So please grab these, because it took a while to find them. What happened here?
Let me pull up the chat.
Oh no, I don't know if the links are going to copy. Nope, the links did not copy. Let me see if I just
Not copy.
no. So what I will do is I will just grab this here. These links, oh, I'm sorry, those are warm-up questions that I offer in my videos. Down here are the slides. So I'm just going to grab all this stuff and I'm going to mail it to you.
Okay. Sorry if I'm looking over here. It's good. I have 4 screens.
Oh, that's good. I have 2. 4. I would love 4.
Yeah. I
Hmm.
actually have 6, but or 7.
And if you watch those videos, you'll see these warm-up questions I do at the beginning of class. And there's a special e-polling interface we use. And if you want access to that, you just let me know. Okay. You have all the stuff there. And if there's anything, is there anything else?
Nope. No. Your TAs are here. I'll let you all go and have a good day.
Thanks. And I'm going to stop the recording.